let's do another example with dynamics. In this question, we have a crate of mass 29 kilograms, and it's being pushed by a person with a horizontal force of 144 newtons, and it's moving at a constant velocity. And it's asking us to find the coefficient of friction. So let's start off this question by drawing a free body diagram. So free body diagram. And to draw a free body diagram, I'm just going to draw a box here for our crate. And we know its mass is 29 kilograms. So I'm going to write 29 kilograms inside the box. And I'm also going to draw a ground for the box to rest on because their box is not floating in the air. So the ground is an important thing to draw. Now let's draw the forces that are acting on this crate. We know from the question that it's being pushed with a horizontal force of 144 newtons. It doesn't really tell us which direction, so I'm just going to, and that's because in this question specifically it doesn't matter, so I'm just going to assume it's to the right. I'm going to label that 144 newtons. I'm going to label it pushed because this is a push. This is the force as a result of it being pushed. So what other forces are acting here? Well, we always have the force of gravity as long as we are on Earth. So F gravity. And the force that's opposite to the gravity, because the crate is sitting on the ground, we have an equal and opposite force to the gravity called the normal force. So we'll call it F normal. And then because our crate is being pushed, our crate's being pushed this way, there's going to be a friction force acting in the opposite direction. So there's going to be a force of friction that is acting in the direction opposite to the motion. So F friction. Remember, the friction force is always opposite to, the direction of the friction force is always opposite to the direction that it's actually moving. So now that we got our free body diagram drawn and labeled appropriately, let's move on with the question. And we know that since the velocity is constant, so remember in the question, we have a constant velocity. That gives us a piece of information. We know that the acceleration will be 0. Our object is not accelerating, it's moving with a constant velocity. And that's important because our formula, that F net is equal to ma, that'll tell us that the F net is equal to m times 0, that the F net is equal to 0. So this is important to realize when you're doing these problems, that the net force when there's no acceleration is 0. So you'll see this come up later in the example when we're doing our calculations, that the net force being 0 will help us to solve this problem. Now, we're going to have to start calculating some values for these forces. So let's start off with the y-axis, the force of gravity, and the normal force. So this is going to be just in the y-axis, just in the y, I'll call this the y direction. And if I'm going to call it y direction, I better label this y and x. I'm going to label my axis when I'm doing this problem. So in the y direction, we have a normal force and we have force of gravity. And since we're resting on the ground, our object is not moving up or down. it is resting on the ground. So what we know based on that is that the force of gravity is equal to the normal force and vice versa. So we can write that out here. We can write that out. So the normal force is equal to the force of gravity. And now we want to solve for the normal force. And we know that the force of gravity is m times g. Remember the formula, Fg, force of gravity, is equal to the mass times g, and g is 9.81 meters per second squared. So as we continue solving for the normal force, let's plug in our values. So our mass, remember, is 29 kilograms. Remember, our mass was 29 kilograms. And then the gravity for G, the gravity is our 9.81 meters per second squared. That's the constant that we all have memorized. So now all we have to do, we have to plug this into our calculator. That gives us that the normal force, and I encourage you to type this in your calculator to see if you get the same answer, 284.49 newtons. So that's our normal force. Now let's move on. Well, let me show you this. So our normal force, that value we calculated, 284 newtons, that's going to be the value of this force. And another thing, since Fn is equal to Fg, that's also going to be the value for the force of gravity. So now let's move on, going in the x direction. So here we're going to be looking at just the x direction. And the formula we're using here is that F net is equal to ma. So on this side of the equation, we have our net force. And to find our net force, we want to look at these forces that are acting along the x-axis. So that's our friction and the force as a result from being pushed. Whereas where x, a positive x is in this direction. So this is the positive x direction. So when we're coming up with our equation, this is going to be a positive force and this will be a negative force. So here's how we're going to write it out. So F net is equal to our 144 newtons, that's positive, and we have to subtract the force of friction. That is equal to the mass, 29 kilograms, times the acceleration. Now what's our acceleration? If you remember at the beginning of the problem, since we have a constant velocity, acceleration is 0. So this is what I showed you down here. So the F net is equal to 0. So since acceleration is 0, this whole term here is going to go to 0. So what we're going to be left with is that you got this side of the equation for the net force, and on the other side of the equation is going to be equal to 0. So all we have to do is rearrange this equation to solve for the force of friction. So I'm going to be bringing this to the other side of the equation and changing that negative to a positive. So 144 newtons is equal to the force of friction. And just writing that out once again, the force of friction therefore is equal to 144 newtons. So what I want to do now is I'm gonna redraw this free body diagram. I'm actually just gonna copy it and paste it just because that's a little bit faster for us. And what this is our free body diagram with values. So So I'm going to be adding the values that we have calculated. So the normal force, remember we calculated 284. So 284, and the decimals were 0.49 newtons. Remember the force of friction we found was 144. So it's equal to 144 newtons. And the force of gravity, remember the force of gravity was equal to the normal force. Force of gravity equal to the normal force. So our force of gravity is going to be the same. Equal to 284.49 newtons. So now we have, this is the same free body diagram, but now we have the values plugged in. So going forward, we're going to be looking at this diagram with all our values. And remember the question, we were looking to find the coefficient of friction. We're looking for the coefficient of friction. Remember, coefficient of friction is mu. So how are we going to find mu? Well, we know that force of friction is equal to mu times the normal force. So this is going to be the equation we're going to use. So F friction is equal to mu multiplied by F normal. And this here, this mu, that's our coefficient of friction. So that's our coefficient of friction. That's going to be the value we're trying to find. Now with this formula, all we have to do is start plugging in values. So our force of friction, we found over here 144 newtons. That's equal to mu times normal force. Normal force, let's plug that value in, 284.49 newtons. And then all we have to do is bring this value to the other side of the equation. And since it's a multiplication here, we're going to bring it to the other side as a division. So over 284.49 newtons is equal to mu. Now typing this into our calculator, we should get a value for mu. Mu is equal to 0.5061689. We don't care about those decimals after that because we're going to round this answer to 2 significant digits. For mu, we always want somewhere around 2 significant digits. So for our final answer here, I'm going to write this. It's 0.51. And mu is unitless. So the coefficient of friction is unitless. And we can see that because our units here of newtons, they cancel out. And that is the solution to this problem.